Okay, revisiting where we left off on the first video, when you're looking at that piecewise function of the absolute value, and if you know you're approaching 6 from the right side, we were talking in that part 1 video that the absolute value of x minus 6, if that interior is positive, you get the expression itself. You just get x minus 6. So your numerator is really just x minus 6. Your denominator is x minus 6. And of course, these are going to cancel out, leaving you simply with a 1. And that's the nice, quick way that you can evaluate that limit. Now, of course, you could also look at that graphically. You could also look at that numerically. Graphically, you could just type this in for y1 and see what's happening as you move from the right side of 6. But talking about a numeric approach, if you're larger than 6, maybe something like 6.1 or 6.01, plug 6.1 into the numerator. 6.1 minus 6 is 0.1, and you'd have the absolute value of 0.1. Plug 6.1 in the denominator. 6.1 minus 6 would be 0.1. What's the absolute value of 0.1 divided by 0.1? 1 itself. A lot of times that numeric approach is actually something that we use on a calculator, and we'll talk more about that later. For 3b, here we go with x approaching 6 from the left-hand side. Now, if x is being approached from the left-hand side, we're clearly smaller than x. Taking a look at this assignment, this time we're going to choose b. When x is less than 6, the absolute value of x minus 6 becomes the opposite of x minus 6. So this numerator will just become the opposite of x minus 6. Down below we just have x minus 6 itself. You can see these are going to cancel out, leaving you with negative 1. And again, every time you have a negative inside of an absolute value, I want you to realize that the output changes that sign. So like if I gave you the absolute value of negative 7, for example, what comes out? Well, positive 7. Look, what's inside when it's negative? You have to put a negative in front of it. It's like negative 7, or another way of putting it, the opposite of negative 7. That's really what we have in this piecewise definition up here when we see the opposite of x minus 6. In any result here, you could also look at this numerically. You could say, well, if I'm approaching 6 from the left, I'd be plugging in something like 5.9. Plug in 5.9 to the top, and 5.9 minus 6 is negative 0.1, but the absolute value of that would become positive 0.1. Down below, 5.9 minus 6 would be negative 0.1. You can see these quantities cancel out to leave you with negative 1. To look at part C, it's very important to realize that your right side and left side limits are in disagreement. Whenever your left and right side limits don't agree, your answer is does not exist. Taking a look at number 4, it's very important to realize you have another piecewise function, but this time you have 3 possible assignments. Depending on whether x is larger than 8, which we'd call assignment C. If x is equal to 8, that's in the middle with B. And if x is smaller than 8, that's A. Looking at part A here, we've got the limit as x approaches 8 from the right. That means we are bigger than 8. If you're bigger than 8, you're going to go with assignment C. So really what is happening here is f of x for this problem for part A, you're going to be working with x plus 1. When you plug in an 8, 8 plus 1 is 9. And that's your final answer. As you're approaching 8 from the left side, I hope you can see we're going to go with assignment A. Assignment A indicates that your x has to be smaller than 8. In other words, we'll be working with x minus 4. And of course, as you plug in an 8 into that limit, 8 minus 4 would be a 4. So as x gets close to 8 from the left side, our y value, function value, gets close to 4. Again, our two limits disagree in terms of right and left side approaching. We will say that we do not exist. Your homework is going to be the same worksheet that we just worked on from last Friday. This time we'll do 1 through 29, the odds, which is all algebraic work.